Hello. Yes. We welcome you back to our channel, Natural Sciences, grade 8 and 9, with me, Richard, here. Yes, today we are looking at this situation. It says that stars do not live forever, just like people. They are born, live, and as they evolve and age, and eventually die. Yeah, that is it. That there are so many stars in our galaxy at different stages of their evolution. So scientists use this to construct the overall pattern. Yeah, then we come to this question. It says that stars are born in vast, slowly rotating cloud of cold gas and dust called nebula, which is about 100,000 to 2 million times the mass of Sun, with a diameter range of 50 to 300 light years. Yeah, this is the description of the nebula from which the stars are formed. It's a big cloud of cold gas and dust, which is slowly rotating, and that's the one which gives us all the stars we see. And then this says the steps below illustrates the process of formation of stars. So we are going to look at the steps in their order. Yeah, so here comes the steps through which a star is formed. The first one says that slowly rotating cube, a cloud of cold gas and dust. The cloud contract or collapse under gravity, becoming denser and slowly heating up. Remember, at first it was cold. Now, because of the condensing, it starts to heat up. A cloud break up into clumps. Clumps get smaller as it flattens out into a disk. The center of each clump will eventually form the star, and the outer disk of gas and dust will eventually form planets and stars. The center of each clump will eventually form the star, and outer disk of gas and dust will eventually form planets around the star. Okay, so as contracting clumps continues to heat up, a protostar is formed at the center. Further collapsing squeezes the mass more, and when massive enough and the temperature reaches 10 million degrees Celsius, a nuclear reaction starts. And at this phase, protostar is now a star. Yeah, those are the processes. once the mass is squeezed enough and the heat has been generated to such an extent that the temperature is 10 million degrees Celsius, a nuclear reaction starts. A nuclear reaction is self-sustaining. It can continue on its own without any port. So once that process starts, at that level, what was a protostar is now a star, which can sustain itself for a long period of time. Yeah, then the first question comes. It says that, what is a protostar? What is it? A protostar is a ball of gas that is hot, but not hot enough to start nuclear reaction. Yeah, that is it. Yeah, then we come to this case. It says that during nuclear reaction in a young star, 4 hydrogen atoms combine to form 1 helium atom. And the question says, what type of nuclear reaction is this? They say right fission or fusion. So what type of reaction is this? There are 2 types of nuclear reactions. There's fission, which is the splitting of a heavy atom into smaller atoms. And there is fusion, which is the combining of lighter atoms into a heavy atom. So which one is which? The answer is it is nuclear fusion, because we are having 2 lighter atoms, which are hydrogen atoms. Hydrogen has atomic mass 1. So when 1, 1, 1 combine, they form 1 helium, which is having atomic mass 4. So what are we observing here? Small atoms are combining to form a heavy atom. Yeah, then comes this case. It says that a nuclear reaction produces a vast amount of energy in form of heat and light, which is radiated into space. Okay. Then the question says, what is the effect of this energy production on contraction of the star? Yeah, what is it? Actually, this radiation of this energy prevents the star to contract any further. So once nuclear reaction starts, the contraction of the star stops. Yeah, that is that. Yeah, then we come to this case. It says that as the star shines, the disk of dust and gas surrounding the star is slowly blown away by stellar's wind into space, leaving behind planets if they have already formed. And the question says, yeah, what is the cause of stellar's wind? Yeah, the causes are many, but the major ones are radiation, which is heat, radiation, which is heat, and magnetic field. these ones, they tend to sweep the environment around the star. All the dust and the smaller particles and gases are swept away into the space, leaving behind only planets to be surrounding the star. And with that, I would like to thank you for your time. The channel is Natural Sciences Grade 8 and 9 with me, Richard. I would urge you to subscribe, to comment, to like, to share. We believe we are simply the best. See you next time. Bye-bye.